Now today I will discuss about the threshold frequency in photoelectric effect. As I have told you earlier, and this is also given in the laws of photoelectric effect, that there is a certain minimum frequency below which the photoelectric effect ceases or the photoelectrons are not emitted from the metal surface. This minimum frequency is called the threshold frequency. The minimum frequency of the incident radiation on the metal surface below which no photoelectron is emitted from the metal surface is called the threshold frequency, and it is denoted by the term nu naught. So threshold frequency is the characteristic of the metal surface. Threshold frequency is the characteristic of metal surface. It means that the threshold frequency depends upon the metal, so it is different for different material. The threshold frequency is different for different metals, and this frequency of threshold frequency is related with the work function. is related to the work function of metal surface. So work function phi is equal to h nu naught, where h equal to Planck's constant. Planck's constant. And you can see from here that minimum the threshold frequency, minimum the work function, maximum the threshold frequency, and maximum the work function. So we can say that this work function depends upon the threshold frequency. It means that the work function is also different for different material, as I have told you in the earlier video. And there are certain factors which affect this work function. So also they affect the threshold frequency. So threshold frequency depends upon the three factors. Threshold frequency depends upon following factor. Following factors. Number one, temperature. When temperature is increased, the threshold frequency decreases. When temperature of metal surface is increased, the threshold frequency decreases. So this is the factor that affects the, because as the temperature increased, the electron in the metal surface absorb the heat energy and they come closer to the surface. So less energy is required to eject them. The electron in metal surface absorbs the heat energy and come closer to metal surface So less energy is required. Is required. To eject them from metal surface. Metal surface. So this is now suppose the metal, this we take metal, and here the radiations that fall on it. This the electron that is emitted from the surface. So this is electron. This is the incident radiation. These are the electrons. This is the metal surface. Metal surface. This is the incident that falls on it. So when the electrons are very close to the surface, this surface, then less energy, the beam of less energy is required to eject the electron from the surface. It means that the work function reduces. So if we take the temperature, if the frequency nu naught, work function phi, if temperature increases, this decreases and this also decreases. So when temperature is increased, the threshold frequency decreases and the work function also decreases. Now the second factor. Contamination of surface. If metal surface is oxide coated, the threshold frequency decreases. It means that the alkali metal have the less threshold frequency. The alkali metals have low threshold frequency. This is why that the alkali metals are preferred for the photoelectric effect. For this reason, alkali metals are preferred for photoelectric effect. It means that the light beam of low frequency is required for the alkali metals. So this is why that the oxide coated material are usually used. So the example of this one is your barium oxide, strontium oxide, chromium oxide, etc. So all these such kind of oxide coated materials are most preferred for the photoelectric effect. And the third factor, nature of metal surface. Nature of metal surface. Threshold frequency. Varies from metal to metal. It means that this is different for the different materials. So it is dependent upon the structure and the chemical composition of the surface. It depends upon structure and chemical composition. Of metal surface. Metal surface. It means that if they have different chemical composition and different structure, the structure is like that, the crystal structure, the FCC, BCC are like that, then this threshold frequency also affected by that. So this is why that it is different for the different materials. So these are the factors that affect the threshold frequency, and this threshold frequency is related with the work function of the metals. So work function is also depending upon these factors. It means that work function and frequency are simultaneously affected by these factors. So this is what the threshold frequency. So always remember that this is being the frequency, it is the dimensions of per second and it is a scalar quantity. So you all like, share and subscribe the video. Thank you very much.